use of alternating electric fields as an anti-cancer therapy in glioblastoma, as well as studying advanced neuroimaging for earlier detection of recurrence in aggressive brain tumors.
Hello, good afternoon. I'm Reinhard Schulte. I'm a professor of radiation research at Loma Linda University. I'm a physician scientist. I worked most of my life, my professional life, to promote proton therapy as a more advanced form of radiation therapy. And it took much longer than I thought, but now so Loma Linda was the first proton center. Now we have more than 40 in this country. We still have to establish the reason for higher cost. So it's an important topic to advance new technologies, not just particle therapy. There are many other cases. So that's my main interest. I'm particularly interested in treating, maybe curing malignant brain tumors.
Great. Best for the last.
Thank you. Thank you. My name is Akitsugu Kawashima from Tokyo, Japan. My specialty is vascular neurosurgery, especially bypass for myelin disease or complex aneurysm surgical treatment. I'm happy to join this discussion. I'd like to, from the view of my specialty, to discuss. Thank you very much.
Fantastic. Great, great. Okay, so we're going to have a live, basically, panel for our audience and the public. So I respectfully request to make your comment in a way that the public audience could kind of absorb that. So we start with Dr. Kim. You started a great consortium of metastatic tumor, and you have been driving a great 40s conference with us. So can you give us a highlight of this consortium and tell us what is new in the area of brain metastases?
So partnering with Sbmt for the opportunity to continue highlighting what we as a research community have identified as key priorities and areas of unmet needs for brain metastasis research and treatment was a wonderful opportunity. And it comes on the heels of a couple very focused NCI workshops that we conducted last fall and again a couple years prior, which was intended to bring together key stakeholders, including patients, patient advocates, NCI, FDA, professional societies, basic science, translational and clinical researchers, to identify the areas of unmet need for brain metastasis through which we hope to have more coordinated efforts across institutions, consortia, even the NCI-funded cooperative groups to be able to inform high-impact clinical trials and ultimately deliver improved therapies for patients. And so a couple or several of the priorities that were outlined at these stakeholder workshops were what we selected as session focus for the first 3 days of this meeting. And on the first day, we focused on the really significant area of unmet need of sort of preclinical and clinical work towards the prevention of brain metastasis, for which I'm not aware that there's really ever been a session at any scientific conference that's focused specifically on that. And we began the session most appropriately with a patient describing their brain metastatic journey to really center and to form foundation for why we are even here, discussing these advances and the potential avenues for improvement. And so there's key work that's being done, some of which is NCI funded, out of a work of a number of investigators that presented at this conference that are moving towards that, but unfortunately, very, very few clinical trials that are actually dedicated towards investigating potential avenues for prevention. I know of pretty much only one that's evaluated, secondary prevention, and so this was highlighted as a key area, and actually will be a continued focus as we plan subsequent workshops and symposia towards the latter half of this year towards focusing on this topic. So clearly an area of unmet need. The second day, today, we dovetailed on this discussion with a focus on the early detection and treatment of brain metastasis through the use of imaging, potentially circulating, and other biomarkers to focus on this area. And again, this is an area that has been identified through multi-stakeholder discussion as a key area of unmet need that is pivotal because in being able to focus on earlier detection, we may thereby be able to reduce the morbidity of treatment and improve outcomes for patients. There, as a consequence of these discussions and because of previous work, will be hopefully industry academic partnerships that arise to tackle this issue. And finally, tomorrow, as a plug for those of you who will be attending, our last 8 a.m. session will be focused on leveraging real-world data using large-scale data analytics in order to inform our clinical trials and best clinical practices. So learning from every patient with brain metastases. This is going to be a discussion with leaders of researchers, of data consortia, and projects that are discussing how we may convene as a research community to leverage data from our EMRs, imaging, pathology, as well as clinical data in order to identify high-risk patient subsets that could benefit from our clinical trials and more tailored clinical treatments. And so this is going to be a discussion that, again, is going to dovetail with subsequent workshops later in the year and ongoing initiatives so that we can hopefully move the envelope in a more coordinated fashion as a research field and as a community.
Fabulous, great. Well, that's a great snapshot of the brain metastases. So, Dr. Patil, you spearhead the great group of multidisciplinary neurosurgeons, oncologists, and radiologists, and so on. So, you had a series of case presentations, right? So, tumor boards. Do you want to talk about that? And but again, for the general public, folks who are watching us on our brain mapping TV on YouTube, they may have family and friends or themselves have metastatic brain tumor or brain tumors in general. Can you basically in few minutes tell us what are the recent advances, what's coming up, and any clinical trials or anything exciting?
Absolutely. Yes, as part of the Sbmt meeting this year, we've initiated a series of tumor board meetings since yesterday, and then it'll go through Sunday, where yesterday we talked about benign brain tumors. Today we just finished the session on low-grade gliomas. Tomorrow will be the session on pediatric brain tumors, and then on Sunday we'll have the tumor board focused on high-grade gliomas. And essentially, the tumor board is an opportunity for all the specialists to come together once a patient, is found to have cancer, and the tumor is removed by a surgeon. We then convene a tumor board where we have specialists from pathology, from radiology, radiation oncology, medical oncology as well, and then, of course, our colleagues in surgery and neuroradiology who all contribute to reviewing the case and getting it a diagnosis so that we can then formulate a treatment plan. We've been very fortunate to have colleagues from the University of Texas MD Anderson Cancer Center and Children's Hospital of Los Angeles forming the tumor boards for this meeting. And I think one of the things that has come up is when we discuss the cases and we talk about treatment options for the patients, there are standard therapies available that are based on evidence from prior clinical trials that were found to be successful. But at the same time, for certain cancers, even those therapies, although they are standard of care, at some point will not be sufficient, and then the tumor will grow back, or will have what we call disease progression or tumor recurrence. At that point, we do have some second-line therapies that are available, but a lot of what we focus on are clinical trials, where we take the most promising therapies from the lab and then put them into human patients for the first time, with the hope of getting a benefit for these patients when they have either new tumors or in most cases when they have recurrent disease. And I think that's something we may touch upon later today in this panel, is how do we really translate findings from the lab to quickly get those therapies into clinical trials so that they can be available to patients who need them in a way that's expeditious, but of course at the same time safe, so that we can more quickly get to determination as to whether a therapy is effective or not prior to going for FDA approval, which would then make it available for other patients around the country and then eventually around the world.
Fabulous. Dr. Schulte?
Yes, so my role in this neuro-oncology track is to, we had to start organizing it some years ago, so I don't have any particular emphasis on it, but finding the right people and the right structure to discuss what are the most pressing topics in neuro-oncology. So this is the neuro-oncology track. And I think we started from just having a few isolated sessions at meetings maybe 5 to 10 years ago to organizing it in a more straightforward fashion with the goal to bring experts together. Not only the clinicians, but also the basic scientists, the PhDs, and even sometimes postdocs are allowed to give a talk. So we think this really becomes a think tank, and also to identify advances. There's a lot, of course, in drug and in targeted therapy, drug development, biomarkers for early detection, which allow better approaches in terms of less side effects, like we have discussed for brain metastasis. But from my side also, new technologies, and sometimes they're very expensive. And those often fall to the wayside because NCI is known not to fund technology development. And I think that's a mistake. That rule was broken once in the last 15 years when it came to President Obama's attention that actually patients with brain tumors, base of skull tumors, for example, have to go to Japan to get carbonine therapy. So he said, why is that so? Are we not developed enough to do it here? And so at that time, NCI and Department of Energy, DOE, which is mostly physicists to develop, advanced forms of energy use, but also responsible for accelerator development, which is required, came together in a workshop. And I had the privilege to attend that workshop with about 60 other experts. And I think that was an exceptional example of a think tank where really people from many different backgrounds, both physics, engineering, even mathematics, clinicians, radiation oncologists, neuro-oncologists, and basic scientists came together. And that kind of was the model for me to organize this track together with Vicky. And I hope we definitely have not been perfect. We'd like to see more audience, so we offer CME now for clinicians and attract them, so we'll definitely continue this scheme. But we also pick certain technologies that we think are worth presenting at our Brain Mapping and Therapeutics Day in Congress to the policy makers and hopefully, make progress there too, because that's a big requirement for success.
Great. Speaking of audience, you're live for millions of people. So I think it's a great privilege to have Dr. Gaston with us. Thank you for joining us. Can you introduce yourself quickly?
Yeah, thank you so much. Natasha Gatson here. I am, thank you. I am the director for the Center for Neuro-Oncology at Indiana University. I'm a professor there of medicine and neurology and a neuro-oncologist directing that center. I'm really excited to be here and really interested to talk about this piece I was invited to speak about this year, innovations, more so than inventions, really not starting from the ground, but making what's available better and showing how that can help with patient compliance. And I think it's a great addition to this wonderful conference. Thank you for having me.
Pleasure, and you're a lifetime member.
Yes,
So
thank
thank you for joining us. Okay, we'll go to President Abhilash Haridas. So your thought on the state of brain cancer therapy. Where are we now? Where should we be 5 years from now, 2 years from now?
Yeah, thank you. So when I think of, and as a neurosurgeon taking care of not only adults but children with brain cancers, it makes you dig a little bit deeper as to prevention is better than cure. So we have to focus our attention on why are we getting these cancers, and is this something environmental? In the last year, you probably have read articles online in the news about microplastics in your food. Even microplastics being found in brain specimens on pathology. So I think the point, not the point of that, but something I think about is plastics have been around, it's convenient, but now we are facing some unintended consequences of that convenience. And that is exactly the same way I think about technology and innovation and artificial intelligence. Like it's an incredible tool, but if we don't use it the right way, we may not get the answers that we're looking for. In fact, we may end up with more problems. So I just want any thoughts into preventing cancers to move in that direction. And earlier, yesterday in one of our talks, we talked about black bone MRI from one of our speakers, specifically looking at MRI sequences that can mimic bone quality, so you don't really need a CAT scan, which is a major deal for our pediatric patients. CAT scans are x-rays and radiation, and this can induce not only cancers, but leukemia as a child grows. And if you're the parent of a child with cancer, these tests have to be done. So I'm glad that that's where technology really makes sense. It's changing the way we assimilate data. So I'm hoping that with that, and with the dawn of artificial intelligence, we can use all these innovations in a positive way.
Thank you very much. Dr. Yamamoto, from your standpoint, in terms of cancer research, especially for brain metastases and brain cancer, what are the areas of unmet need in terms of maybe funding or policy?
Funding policy. So, so from my opinion, I feel like we need everything, including a new way to, new technology and research to treat the cancer, diagnosis included, but also policy is also important as well. Because ultimately, for instance, if you have a new treatment, then the patient or hospital will request to have, the cost reimbursed from an insurance company. So often I see that much of a new treatment, the patients, even though after request to get the reimbursement of insurance company, they are denied. And then so often people who can't afford to have this treatment, you basically pay out of pocket, which can be a very issue. So you definitely need, not only the funding, dissemination of a new, finding important, but we really need to actually change the policy. That's what I feel.
Fabulous. Great. Professor Kawashima, the Japanese healthcare system is different than the United States, but I would say it's better than the United States. So what are the difference in this you're pretty familiar for both, and what are the difference you see, and how can Japanese system improve? What the recommendations you have for the US system or global, because you're a global neurosurgeon, you're pretty respected globally. So what's your thought on how can we improve the healthcare system to better kind of provide service for our brain cancer patients?
Thank you very much. From my territory, I'm vascular neurosurgery, and you know, in Japan, there are popular in moya disease, and it's the key is neovascularization, and I think it's a very similar neovascularization between the vascular disease, moya disease, and the tumor in the growing, and the biomarker, for example, VGF or so, is if in the moya disease, some patient, you know, the indirect revascularization after operation. Some patient, the neovascularization is very, very good, increasing, but the other patient, there are no. So it's a very similar, I think, between in the tumor territory. So the finding of the new biomarker or the find the other things is very progressing, improving the treatment in the tumor. So I hope that progressing about this. In Japan, the territory is in the vascular is very improving. So I think that the Japanese such a territory and the U.S. is collaboration is very important. Thank you.
Fabulous. Coming back to Dr. Gadsden, you know, we hear a lot about AI, and we hear a lot about new technologies in this conference, of course, neurotechnologies. So what are your thoughts for the general audience in terms of integration of new technologies coming to cancer therapy and brain cancer therapy? And then is this good news, or is this going to complicate things?
Yeah, so I find what's interesting is that when we talk about AI and we talk about developing new innovations, the point that you made is very clear, and it rings very true in brain tumor, that we have to be careful how we use it. It's so important to get this information, but we run into two issues. One, what do you do with the information once you have it? And two, how does it change? Are we really changing treatment and changing outcomes for patients, or are we reclassifying diseases? So I think that we run into trouble with super overclassification of diseases with new technologies, and instead of adding to the potential to treat. And this becomes a problem when we deal with countries that don't have access to this new or more expensive technology or ways of further classifying tumors. And when we run into that trouble, we limit those other countries from being able to publish in our same journals and actually get the research out there. So I think we have to caution ourselves and watch what we do. It's a very powerful tool. I love it. As a matter of fact, I'll be talking at 4:15 this evening about something that really is on its way to utilizing AI. But the point should not be just to classify disease. It should be to be able to move the needle and offer more therapeutics.
Fabulous, fabulous. Actually, in my keynote on Saturday, I'm going to show you how we use, quantum computing for predictive modeling of brain cancer. But we have 3 minutes, and we're going to go rapid fire, kind of very quick across the committee. Tell us one thing that the audience need to know, either a new clinical trial or new treatment coming up very quickly, and a piece of hope for patients with brain cancer and metastatic cancer. So ladies first again. Dr. Kim.
I would say that I do believe we are at a critical juncture where we are in partnership with our patients and patient advocates as well as advocacy groups, scientists, regulators, funding bodies, and researchers are moving in a coordinated manner to maximize our resources and to delineate clear priorities for how we should address unmet need in brain metastasis research. I think there's been a lot of work kind of operating maybe as separate threads, but for the first time we do see a lot more of a concerted convening, and we look forward to seeing how this is actually going to help shape the landscape of brain metastasis research in the next decade to come.
Fabulous. Dr. Yamamoto.
So probably I'm going to talk about some, thing that I discussed earlier, so which is to change the policy. So if we wish to, let's say, change the policy, what we have to do, we really need to actually talk to your local, assemblyman, assemblywoman, to Congress, personnel in the government. So I just wanted to tell you that our organization, every year, annually, we actually go to Washington, D.C. to have some kind of advocacy activity in which we try to actually educate and inform the government personnel what we have been working on and what are the future of new cancer treatment, for instance, or any new treatment for neurological disorders as well as mental health disorders. Try to convince that what kind of a new treatment on the horizon, and it's really important to change the current policies so that those new treatment will become, let's say, FDA approved, and then also change in a way that those treatment will be actually reimbursable through insurance. So that's what they have been doing. And so anyone who are interested in this kind of activity, even for patient advocacy, we are welcome to invite you to involve in this annual activity. So please join us if you're interested. Thank you.
Great, thank you. All right, President Abilash, 30 seconds.
I'll keep my answer very practical. In the last 2 days, I met so many students and young scientists in the room. I highly encourage you to interact with the faculty here. There are several grant foundations all over the country and around the world that you've brought to my attention, and I learned in the last 48 hours. We should tap into those resources and help us help you get your science off the ground. So. Because you're really the next generation. We are seeing it from a different lens, and you have the technical and mental aptitude with technology now that many, at least I don't confidently possess, so I want you to share that with us. Thank you.
Okay. Dr. Kawashima, go ahead, 30 seconds. Closing.
Thank you. I mentioned before about the myeloma disease, between myeloma disease and the tumor, and the gene of the AVM is the same as the tumor, and the relationship between the vascular and the tumor is there are many the similar things. So that I hope the new technology and the new development is we can find the many it's very simple, or all diseases are may be very simple. So it's my message from in this.
Fabulous, thank you. All right, we're going to go to Dr. Reinhard Schulte. So 30 seconds, any new therapies, any good news for cancer treatments?
Of course, what I presented in Washington was boron neutron capture therapy. That's a new frontier. It's a combination of molecularly targeted therapy, boron compounds, with radiation, low energy neutrons. Both of them are pretty much harmless, but together it creates a fission reaction in the tumor cells. If you bring the boron selectively in the tumor cells, that's the ultimate form of of radiation therapy because it will not affect the normal tissues. So even if you have infiltrating tumor cells. So Japan, again, leading, the US lagging behind, but we can do it here. So NCI, please listen. This is an important development we should not miss.
Fabulous, great. Well, best for the last. So, Dr. Patil.
Well, one ray of light that came out of our discussion today, the low-grade glioma tumor board, was the new drug that was recently approved called vorasidenib for patients with IDH-mutated low-grade gliomas. And what this raised to our attention was that the FDA is now evolving in terms of being more flexible with endpoints for clinical trials, not looking at just overall survival, but even if a drug delays the time until the tumor grows again, was sufficient in this trial to lead to an FDA approval, which now allows for this drug to be available for patients with low-grade glioma. And there's not been a therapy for this population for more than 4 or 5 decades. So now, of course, with the new drug that's available, we had a lot of discussion today at the tumor board as to which patients to use it in safely versus our standard therapies. But that's also exciting because now we have further options to make available for our patients. So we hope that this becomes a template for future innovation and future recognition by the FDA that sometimes for clinical trial designs we have to be flexible in regards to FDA approvals for chemotherapy drugs that are not just limited to an overall survival benefit. So I think that's definitely a ray of hope for us.
Fabulous. Well, I just add on to that you all covering neurological disorders in this conference, from neurotrauma to brain cancer, Alzheimer to dementia, and even spinal disorders. Most of these diseases are caught later after they are progressed in the patient. So one of the policies we are pushing through Society for Brain Mapping and Therapeutics is creation of kind of a brain screening. So actually we detect these, let's say, unruptured aneurysms. So we detect early, we act early for brain tumors. We find about them when it's too late. So I think having that screening upfront is important as a matter of policy and science, but also because of that, you can basically collect a lot of data and use data analytics for predictive modeling. So with that, I congratulate and thank our panelists, and thank you for watching us online. Thank you. All right.